So thank you to Ajin and to Peter and to Pidang for their assistance with this. What I saw interestingly yesterday was that um, there are a class of functions which, if you apply the trapezoidal rule or you apply Simpson's rule, they give you the exact answer to the area. So the area given by trapezoidal rule or Simpson's rule will lead you to actually having um, the exact area. Now, I don't mean simple ones like linear functions or in the case of Simpson's rule, quadratics or cubics. This particular function is a cubic, but the reason that in fact it doesn't matter that it was a cubic. Um, Notice that the trapezoidal rule still gives the exact answer. So it is more to do with the nature of the function than it has to do with the fact that it's cubic. Um, Now, so you'll notice in here that g of x is equal to x minus 3 cubed plus 4. And when you do the integration from 1 to 5, it gives you 16. If I apply the trapezoidal rule, the answer turns out to be 16. That's with 4 sections. And Simpson's rule with 4 sections also leads to the answer being 16. Now, that was kind of interesting for me. Where it came from was a question I wrote actually much earlier, which did mess with me for a while. Um, Now, with this particular function, um, crazy stuff was happening in that. So notice that the function is um, related to cosine, it's the square of the cosine function, and also inverse cosine as well. And when the integration turned out to be 3.14159, and I did the integration again using Simpson's rule or using the trapezoidal rule, the answer came out as the exact answer. And that was interesting to say the least. Um, what I realized ultimately was that what was happening was any time that the function itself um, has a point of inflection, and around that point of inflection, the function has rotational symmetry. So you can appreciate with it pretty much any cubic, when you rotate them around the um, axis around the point of inflection, it has rotational symmetry. But what's true up here is it's not quite that way. Certainly with this function, um, it doesn't have rotational symmetry. However, you could break the problem into two parts and consider that between negative pi and 0, the function has rotational symmetry, that the first part of the piecewise function. The second part from 0 to pi also has rotational symmetry around its point of inflection as well. So that led to, because the number of sections is now 4, essentially the number of sections had broken this into two problems. One where you are applying Simpson's rule and trapezoidal rule to the first part, and then where you were applying it to the second part, both of which had that rotational symmetry. Um, so anyway, that was pretty much it. And thank you for this conversation. Again, Padang, Peter, Ajin, your help was most useful. Thank you.